Hello everyone, welcome back to my channel. So in this video we are going to learn the concept of impulse response, that is overall impulse response of interconnected networks. Okay, so overall impulse response of any interconnected network. If you are first time to my channel, please consider subscribing and encourage me to do more videos like this. So impulse response of interconnected networks, so we have two concepts or two simple points which you have to remember. So if the impulse response of two circuits being H1 of n and H2 of n are connected, okay, so two circuits whose individual impulse responses H1 of n and H2 of n are connected in parallel, then what is the overall impulse response is sum of individual responses. That is impulse responses, sum of individual impulse responses. That is, when you have two systems H1 of n, two systems with impulse responses H1 of n and H2 of n, which are connected in parallel, okay, this is your output y of n and this is your input x of n. So two systems whose impulse responses H1 of n and H2 of n are connected in parallel, then so this system is equal to, so single impulse response we are writing, okay, so that is what it is called, that is why this concept is impulse response of interconnected networks. So this is x of n and this is your y of n, then total impulse response, here I have written or connected in parallel, then overall impulse response is the sum of individual impulse responses. So it is equal to H1 of n plus H2 of n. Okay, so just remember this point. So this is the important point. Okay, they may ask you directly or give you some question on this. Okay, so we'll solve problems also on this. Okay, second point, if H1 of n, two systems with individual impulse responses H1 of n and H2 of n are connected in cascade, then overall impulse response is convolution of individual impulse responses. Okay, that means if there are two systems whose impulse responses are connected in cascade means output of one is given as input to the next one. So this is called as cascade connection. If this is your y of n output and this is where you are applying the input x of n, so the overall impulse response of this cascaded network, this is called as cascaded network, is given by, so that is, it is equivalent to overall impulse response H of n is equal to H1 of n convolution with H2 of n. So this is your output y of n and this is your input x of n. Okay, so just remember these 2 points. Now we'll solve some problems on these points. Okay, right, we'll see one question on this. So he has given, consider the system shown below. So this is the system which you are given with. with some values of h1 of n and h2 of n, and you are asked to find the impulse response of overall system. Okay, so you just have to find the impulse response of overall system. Okay, so impulse response means response due to impulse input, response due to impulse input. Okay, so that means in this case, if you want to find impulse response, x of n is equal to del of n. Okay, so that is what impulse response means, response due to impulse input. That means x of n is equal to del of n, you have to remember. So if you observe here, right, up to here, okay, so up to here, what is the overall system value, overall value of this? So it is the sum of two elements. One is x of n directly given to summer of, so this is the summer circuit, so for which one of the input is x of n, the other input is h1 of n. So up to here the value is x of n plus h1 of n. Okay, yes or no? So x of n plus h1 of n, so it will be x of n plus alpha power n into u of n. So but x of n is equal to del of n, so I can write it as del of n plus alpha into u of n. So this is the equivalent value up to here. Okay, so I am redrawing that. So this is your x of n. Okay, so the total value here is del of n plus alpha power n into u of n, and next it is cascaded with h2 of n, which is alpha power n into u of n. Okay, so this is y of n, and this is your x of n, which is del of n. Okay, so the overall impulse response of the system is convolution between these two. Okay, so overall impulse response will be convolution between these two. So overall impulse response, I am taking it as y of n is equal to alpha power n into u of n convolved with del of n plus sorry, what is h1 of n? h1 of n is not this, so I'm sorry, it is beta into del of n minus 1, beta into del of n minus 1. So here also beta into del of n minus 1. I'm really sorry, so I have not seen that. Right, so beta into del of n minus 1. Okay, so this is your overall impulse response. Okay, so what is this value? So we can split into two parts. Del of n convolved with alpha power n into u of n plus beta into del of n minus 1 convolved with alpha power n into u of n. So from the properties of convolution property of impulse, convolution property of impulse function, we know that x of n convolved with del of n is equal to x of n only. Okay, so this is, if you think this is x of n convolved with del of n is x of n only, that is alpha power n into u of n. Okay, so this is the property of impulse. Next, a shifted property, that is if there is any shifting. Okay, so x of n convolved with del of n minus n naught, so it will be x of n minus n naught. This is also the convolution property of impulse. Okay, so this we have already discussed in the previous video. Okay, so here n naught value is going to be 1, so beta is a constant, you have to write as it is. So this is your x of n. Now we have to perform x of n minus n naught, that is x of n minus 1. So this is your x of n, and now we have to write x of n minus 1. So beta into x of n minus 1. So alpha power n into u of n. So what is x of n minus 1? So x of n is alpha power n into u of n. Then x of n minus 1, wherever you have n, substitute with n minus 1. So it will be alpha power n minus 1 into u of n minus 1. So plus beta into alpha power n minus 1 into u of n minus 1. So this is the overall impulse response. Okay, so first of all you have to use the property. So you have to use the property of you have to use the cascaded network property. Okay, so cascade, when they are cascaded, overall impulse response is the convolution of the two impulse responses. So that is what we have written here, and then you have to use the property of convolution property of impulse in order to solve this question. Okay, so see the second question. He has given the interconnected network and they are asked to find the overall impulse response. Okay, same procedure. So y of n is equal to the first h1 of n convolved with h2 of n. So h1 of n convolved with h2 of n. Okay, because when input is impulse, then overall impulse response is this one. So it is equal to x of n minus 1 by 2 x of n minus 1 convolved with 1 by 2 whole power n into u of n. Okay, and you are finding impulse response, so but x of n is equal to del of n. So del of n minus 1 by 2 into del of n minus 1 convolved with 1 by 2 whole power n into u of n. So wherever x of n is there, you have to substitute with del of n. So it can be splitted into two parts. Del of n convolved with 1 by 2 whole power n into u of n minus 1 by 2 into del of n minus 1 convolved with 1 by 2 whole power n into u of n. So same by property, convolution property, x of n convolved with del of n is equal to x of n only. So this is x of n convolved with del of n, so it is equal to x of n only. So 1 by 2 into u of n minus, same here also, x of n convolved with del of n minus n naught is equal to x of n minus n naught. So n naught value is 1, so 1 by 2 is a constant, so just substitute wherever you have n, substitute it with n minus 1. So u of n minus n naught, so x of n minus n naught, so it will be 1 by 2 whole power n minus 1 into u of n minus 1. So now what will become 1 by 2 whole power n into u of n minus, so this is all 1 by 2 whole power 1, so this is of the form a power m into a power m plus n. So n minus 1 plus 1, so minus 1 plus 1 will get cancelled, so you'll get 1 by 2 whole power n into u of n minus 1. So if you take 1 by 2 whole power n common, so you'll get u of n minus u of n minus 1. Okay, so what is u of n? So u of n is all the values right from 0. You're having the values from 0 to infinity whose amplitudes are 1. And what is u of n minus 1? U of n shifted by 1, that is it starts from 1 instead of 0, it starts from 1. So it starts from 1 and then set up to infinity whose amplitudes is also same. So if you take the difference of these two, so at amplitude 1 its value is 1 minus 1 which is equal to 0. At 2 also it is 1 minus 1 which is equal to 0, and 3 also it is 0, and so on up to infinity it is also equal to 0. So at 0 its value is u of n minus 1 value is 0 and u of n value is 1, so you will get 1 minus 0 which is equal to 1. That means it is defined only at n is equal to 0. So if you draw that, what will happen? So it is the signal 0, its value is 1. So what is this signal? What is this signal called? It is impulse function, discrete impulse function, del of n. Okay, so I already discussed about this. So this is your discrete impulse function. So u of n minus u of n minus 1 is your discrete impulse function. So what can we write here? So 1 by 2 whole power n into del of n is the answer. Okay, so these are the concepts, and this is how we can find the impulse response of interconnected networks. Okay.